So this video is on the integrated one, chapter 8, D-Day. And again, use this as a reference for ones that you're stuck on. So on this very first problem, Aaron just inherited $6,000 from his grandmother. Okay, so he got $6,000 that he inherited from his grandmother. He plans to invest the money, not touching it for 20 years and keeping it for 20 years. Fill in the table below, assuming he invested it in treasury bills at 3% interest compounded annually. So the minute you see this compound interest means that it's going to be exponential. And if you think about it as a sequence, that means it's geometric. So we're timesing by something over and over again. So when we're looking at this and we see the 3% interest that we're gaining, I basically take 100% less 3%, and now we have 103%. And as a multiplier, that is 1.03. So that's going to be my multiplier. So in this situation, we're going to be starting with 6,000. I am going to write an equation. I'm going to jump down to letter C, where letter C says write an equation to represent the amount of money as a function of the years. So I'm going to do y equal 6,000 times 1.03 to the power x. That's our equation. So if we're going back to the table, we can continue to multiply 6,000 by 1.03 and the next one by 1.03 and so on. Or what we can do is we can put it into our graphing calculator and generate a table there. So I'm going to get my calculator. Okay. And to put it into your equation, you want to use the y equal. So you're going to press y equal, and then you get this. And we're going to type in 6,000 times 1.03, and then raise to a power. And the raise to a power button is right here. This raises it to a power. You're going to press that. And then we're going to raise it to the power x. And this is where x is, right here. Okay. And so there we go. We have 6,000 times 1.03 raised to the power x. And I am going to go to the table. Now the table is on this button here that says graph. It's blue. It's hard to kind of tell here in the video, but it is blue. So anytime I want anything that's blue, I use my blue second. Anytime I want anything that's written in green, I use the green alpha. So I'm going to press the blue second and graph, and it's going to give me a table. And so here's my table. Now, when you're using this table, what you want to make sure of, and here, let me make this a little bigger. Move it over here, make it a little bigger. So when you're doing this, what you want to make sure of is, I like to come to the y and highlight the y because this only allows so many digits. So sometimes you might not see the whole entire number. So I'm going to come over here and you see that it types it down here. So 6,000. My next one's going to be 6,180. So I'm going to go 6,180. The next one is 60. So $6,365.40. And when I go to year 3, I get $66,556.36. That 2 after the 6 is going to keep that as a 36 and not push it up to a 37. And then these dots here mean if the pattern continues. Okay, so as the pattern continues, let's say we go up to year 20. So if you want to go to year 20, you can either come here and just keep scrolling down, or you can move over onto your X. And here's your 20, and that is going to be $10,836. And that 66 is going to be pushed up to a 7 because of to a 67 because of the 7 after. So 67 cents. And that's your table. So now what we're going to do is we're going to make a sketch of this. Okay. So I'm going to draw my y-axis and my x-axis. And my x-axis is going to be number of years. And my y-axis is going to be money. And what's going to be happening is I am going to have, for all these exponential graphs, you always are going to have an asymptote on your y-axis. I mean, on your x-axis, sorry, at y equals 0. Okay, so this is y equals 0. We've got that asymptote. And then what's happening is we're going to be having a situation where we're going to be starting at, make this a little thinner, starting at, let's say 6,000. So let's say this is 6,000. And then it's going to be increasing like that. So there's a sketch for me. Okay, I need to see where it starts. I need to see if it's increasing or decreasing, and this is increasing. I need to see the asymptote drawn in, and I need to see the equation. Okay, so now there's a second component to this. So down here, we have Simple Sally, and she says that, that she has a better deal, okay, than the one that Aaron had. So Simple Sally says there's 5% simple interest for 20 years. What investment should Jose take to make the most amount of money? Okay, so when you see simple interest, this means it's linear. And in terms of a sequence, it's arithmetic, where you're adding the same amount. Okay, so what's happening in this problem, unlike this compound interest one that is an exponential equation, this is not going to be an exponential. So what's going to happen is we're going to be investing, we're going to be earning 5% of our original amount. So I am going to take 6,000. I am going to times it by 5%, which is 0.05. We're not doing this as a multiplier. I just want to find 5% of 6,000. 5% of 6,000. So if I come to my calculator and take 6,000 and then times it by 0.05, that's 5%, I get $300. So what this means is we get $300 each year. Okay, so we're going to be increasing by $300 each year. So this equation is going to be y equal 6,000, and this time we're not timesing, we're adding 300 every year. So that's going to be our equation. Okay, so now at this point, what we want to do is we want to see which one would be better investment over 20 years. So for the first one, the exponential one, we see that in 20 years, it's $10,836.67. We need to figure out what it is in this one for 20 years. So I'm going to put in 20. And so I am going to have 6,000 plus 300 times 20. And when I put that into my calculator, I'm going to get 6,000 plus 300 times 20. So I get $1,200. So what you'll notice is this one, that's simple interest and really grows slower over time, but I am starting with a higher percent. In 20 years, it is going to be more, okay, So this one here, which is my simple interest, is going to be more than my compound interest, okay? So again, we are comparing this one here. Let me just kind of color code it. We're comparing this one here with, I'll do this one in yellow because I've already written it in blue, with that one here. And so it asks us, well, what is a better situation? So in this case, if I'm dealing with this, let's see, so by the 20th year, by year 20, Sally's simple interest at 5% will be worth more. Now, if I was to put this into my calculator and I went to y equal, and I keep that one there and I put in this new one, 6,000 plus 300, not 3,000, so 300x, okay? And I go back to my table. So again, y equal was what I just did to get to this screen. And then if I want to see the table, I'm going to do second and table. And here I can see that if I started at year 0, okay, year 0, they both were at 6,000. Here, this one is actually worth more, the simple interest one. And you see it is worth more. Still worth more. Okay, still worth more. Still worth more. Now, all of a sudden here at year 33, you see that even though the 3% interest is less than 5% interest, if it's compound interest, it's actually going to be a better deal after 33 years than the 5% simple. And you see, as we keep going, it's going to keep getting bigger and bigger and bigger than the other. So simple interest is good until year 33. At year 33, the compound interest is better. And here, let me just clarify, it is worth more. Simple interest. Earned 12,000, or I shouldn't say earned, led to $12,000 in 20 years compared to the compound interest that was only $10,836.67. Okay. And again, at year 33, the simple interest is going to become less at year 33 than the compound. Okay. So these problems down here, they want us to write an equation. Okay. Now, if you're thinking about this, you can make a table for yourself if that helps you. We have 0, 7. We have 1, 4. This is going to be my A. This is telling me that A, let me write it on this side, that A is equal to 7. So these equations should always be y equal A times B to the power X. So I find my A. I know that for this 4 here, it was 7 times my b. And so if I solve that by dividing both sides by 7, I get that my b is going to be 4 sevenths. So the equation is going to be y equal a, which is 7, times 4 sevenths to the power x. Similar idea on the next one. Again, if I was going to make a table for this one, I have x and y. I have this point here is 0, 7. I have this point here is 1, 35. So again, we see that our a is 7. And then I am multiplying, just circle this a little better. I am multiplying 7 by something to get 35. So when I solve, I get my b is 5. So our equation is going to be y equals 7 times 5 to the power x. Okay, so looking at number 3, you saw a note that read more seagulls. The number of seagulls at lunch is equal to 2 times 3 to the power x. Assume x represents the number of days. How many seagulls were there in the start? So when we have this equation, again, let me just kind of write y equal 2 times 3 to the power x. This 2 is our a. It is our start. So when it says how many seagulls were there in the start, there were 2. What is the multiplier? The multiplier is this 3. That is our b. Again, it is our multiplier. So the multiplier is 3. How many seagulls are there on day 5? So basically, we're going to take y equal 2 times 3 to the power 5. And we're going to put that into our calculator. And so when I do that, I'm going to go 2 times 3 raised to the power 5. We end up with 486. 486 seagulls. When will there be more than 1,000 seagulls? So what we can do is we can guess and check, or you can put this into your graphing calculator. Okay. So if I go to my y equal and let me get rid of these 2 equations, I'm going to go 2 times 3 raised to the power x. And I'm going to get my table again, which is my blue second and graph for table. Okay, and I want to go back to start. Let's see, let me make sure I have my equation 2 times 3 to the power x. So I'm going to go back to my table. I'm going to go up to until I see what I'm looking for 1,000. So we know that day 5 is 4,086. Day 6 is 1,458. So in between day 5 and 6, okay, or by day 6, there'll be more than 1,000. Describe a situation that goes with this equation. So this is like a little word problem. So at school today, there were, and this has to be my start, my A. So there were 2 seagulls. each day the number of seagulls triples. Okay, so that would be a situation. On number 4, we are going to be rewriting these with positive exponents. So one thing to remember is if I have this 3 to the negative first power, remember it's really over 1. And if we have a negative exponent, we don't like that negative exponent. So what happens is we're going to move this so that my 3 is now on the bottom, 3 to the 1. And 1 over 3 to the 1 is just 1 over 3, so 1/3. Now this one here, when I have something like this, a negative exponent, again, what it is it really means make the reciprocal. So right here, this is saying, hey, what is the reciprocal? I'll write in a different color. What is reciprocal the reciprocal of 3? That's really what it's asking. This one here is really saying, hey, what is the reciprocal of 1/3? So the reciprocal of 1/3 is 3 over 1 or 3. And here, this is really saying, what is the reciprocal of 4/5? So the reciprocal of 4/5 is 5 over 4. And those are our answers. Okay, on number 5, it says sketch the graph and describe the following exponential function using the following words: y-intercept, asymptote, multiplier, decreasing or increasing. Use arrows pointing to show this. Use arrows pointing to your sketch to help with the explanation. So I'm going to draw an L-shaped graph. Let me draw a better L-shaped graph. I'm going to grab my shapes. Okay. And I am going to draw in my asymptote. So my asymptote is going to be on the x-axis at y equals 0. So let me draw here my asymptote is y equals 0. This number right here, this 4, that is going to be our y-intercept. So our y-intercept is our a, which is 4. So we're going to start at a height of 4. And this is going to be a decreasing graph because of this. Okay, because this is less than 1, so this is a decreasing graph. So it's going to start big, come small, like that. Not going to touch the x-axis. They also ask us for the multiplier, and the multiplier is 0.8. Okay, so we did the y-intercept, we did the asymptote, we did the multiplier, and decreasing, increasing. So there's our graph and our parts. So on this problem, we have this point, and number 1, they want it to be an exponential function, okay? So an exponential function is going to be y equal a times b to the power x. And the minute I see this 0,2, remember this would be in our table as 0,2. That is our A. Our A is 2. I don't know my 1. I do know my 2. My 2 is 200. So I am going to be multiplying my 2 by something, and then my 2b times something, and we're going to solve that equation. So 200 is equal to 2b squared. We are going to divide by 2, and we get 100 is equal to b squared. And when you take the square root, you get 10 is equal to b. So our equation is going to be y equal a, which is 2, times 10, which is b to the power x. And that's going to be your equation. And again, where I got my 2 is from my y-intercept. So number 7, okay, this one's not as pretty. We got some not so nice numbers, but we are timesing by b. So this one right here, let me zoom in, is going to be 32b is equal to 27.2. So I am going to divide by 32, and we get b is equal to, and I'm just going to put it in my calculator. So 27.2 divided by 32 gives us a 0.85. Okay. So for this, we're going to get y is equal to our a, which is 32, times our b, which is 0.85 to the power x. Number 8, we want to find x when f of x is 2. So f of x being 2, that means that our y, that our height is 2. Let me do it in a lighter color. So we want to know what x would give us a 2 back for my answer. So if we come right here, this 0,2, our x is 0. When my x is 0, my y is 2. On number 9, we're going to simplify this. First thing I'm going to do is let's just kind of clean it up a little bit. So on top, 3x quantity squared is going to be a 9x squared. And then I have a y squared and an x cubed. So now what we want to do is we want to simplify. So 2 of these is going to cancel with this, and I'm going to have just left just x, or x to the first. So our answer for this would be that I get 9 y to the second over x. That's your answer. Okay, on number 10, we're going to distribute first. So we're going to get 3n minus 9 plus 4 equals 2n plus 8. So on this side, I'm going to clean up. And so we get 3n minus 5 equals 2n plus 8. So I'm going to minus 2n minus 2n and end up with n minus 5 equals 8. I'm adding 5, so I get n is equal to 13. on number 11, we have a system. When we have one of the equations in y equal form here, I'm going to put that in for y in that other equation. So I'm going to have x plus my y equals 12, and our y is a 2x minus 3. So I get x plus 2x minus 3 equals 12. So 3x minus 3 equals 12. So 3x equals 15. So x is equal to 5. So on 12, we want where the solution to the system, which basically means where do these lines cross, which is right here. So that point is -1 comma -5. And that's going to be our answer. So -1 comma -5, that is our solution. Okay, on number 13. So on number 13, when you're looking for the x-intercept, it's where it crosses the x-axis. And it's this point here at 4, 0. So 4, 0. Or if they just want the number 4. The y-intercept is where it crosses the y-axis, which is here. That's at 0, -2. So that's 0, -2 or just -2. And then if they want the equation of the line, the equation of a line is always of the form y equal mx plus b. And our m is going to be how we're moving from this point to this point. I'm going up 2 over 4. So my slope or my m is going to be 2 over 4 or 1/2. So we're going to have y is equal to 1/2 x, and then my y-intercept was -2, so -2, and that's your equation. Just need your slope and your y-intercept. On number 14, okay, we want to write a recursive and an explicit and a recursive for each of these. So this one we're adding 3, so that means that this is arithmetic. So if I do my recursive first, and the one thing you need to remember is that is not my first term. That is not my a sub 0, that's my a sub 1. Okay, so we got to be careful. So for this, we are going to be doing a sub n is equal to a sub n minus 1. And then we are adding 3. And the very first term that I'm starting with is a sub 1 is 7. Then for our explicit, so for explicit, we're going to start a sub n is equal to 7 times, sorry, not times, I apologize, we're adding, plus 3. And since I am starting with my a sub 1, this is an n minus 1. If you wanted to go backwards and go, okay, what would have been in front of this? If I'm adding 3, then going backwards, this would have been a 4. And so you could have also done an is equal to 4 plus 3 times n minus 1. That's going to give us the same equation. I'm sorry, not n minus 1, sorry, just n. Because this 4 is my 0 term. Okay, that 4 would be my a sub 0. And similar idea for number 15. So on number 15, we are multiplying by 4. So for my recursive, we're going to do a sub n is equal to a sub n minus 1 plus 5. And that is when my a1 is 5. And then if we want our explicit, So if we want our explicit, that is where we have, let me just rewrite that. That is where we have a sub n is equal to our start times and I wrote times, wow, I don't know why I wrote +5 here. I wrote times 4. So this is going to be timesing by 4. Not sure why I wrote that. So times by 4, and I'm going to do it like this, times by 4. So I apologize. This is my recursive. For my explicit, this is going to be a sub n is equal to 5 times 4 to the n minus 1. If I'm going to start there. If I had wanted to go backwards, okay, and find my term in front of this, if I'm timesing by 4, then going backwards, I'm dividing by 4. So you could have also had a sub n is equal to 5/4 times 4 to the n, since this is my first term. And hopefully you guys find this helpful.